What if an AI system wasn't just a single, isolated brain, but more like a living, breathing organism? A digital beehive, where every individual AI is a specialized cell, all working together to create something far greater than the sum of its parts. Well, that's exactly what we're going to explore today, diving deep into the architecture of a real, in-production AI ecosystem.
So the big question we're going to answer in this explainer is this. How do you actually get multiple AI agents to not just coexist, but to collaborate intelligently? How do they learn from the past, organize themselves, and generate tangible, innovative results?
To really understand this anatomy, our journey is going to have 5 parts. We'll start by getting the concept of this digital organism, then we'll dissect its brain and memory, get to know the individual cells that make it up, see the whole orchestra in action, and finally, check out the fruits of all this collective intelligence.
Okay, let's get right to it. What we're dissecting today isn't some project out of Silicon Valley, but a really fascinating innovation from Brazil. We're talking about the ecosystem from Replica AI Solutions based in Maringá, Paraná. It's an amazing example of how cutting-edge AI tech, the kind you usually associate with global giants, is being developed right here, really putting Brazil on the map for intelligent systems. What we're talking about here is a multi-agent system. And as you can see from the project's actual code, like the multi-agent sprint event organizer, this isn't some theoretical simulation. This is a real, live production environment where autonomous agents interact to create value. So you can forget the idea of a single chatbot. Think more like a whole team of digital specialists.
Every organism needs a command center. So now, let's look at how this ecosystem thinks, learns, and, this part is crucial, how it remembers what it has learned.
What we see here is a dual brain architecture, and it's absolutely brilliant. For quick, real-time thinking, it uses a state-of-the-art model like Gemini 1.5 Flash. But for long-term memory, it uses BERT. Think of BERT as a librarian who doesn't just read every book, but converts every single concept into a unique coordinate, like a GPS for meaning. Those are the vector embeddings. Then, FACE organizes all those coordinates, letting the system find the right piece of information almost instantly. It's the perfect combination of speed and depth.
And how does this brain feed itself? Through its senses, a function in the code called carregar dados. It just devours everything. Spreadsheets, PDFs, configuration files, you name it. And it transforms that whole mess of formats into a unified worldview, the datasets bruto. This is the raw material that gives the ecosystem its awareness of the business and the environment it operates in.
So if Gemini and BERT make up the brain, who are the cells that actually carry out the tasks? Let's meet the agents, the specialized work units of this organism.
And here's the secret sauce. The system doesn't use generic robots. It creates personas. As we see in the code, you have Maria Marketing, who's all about innovation, and João Produto, who's laser-focused on results. By giving them clear roles and objectives, the system forces a collaboration between different points of view. It's like assembling a high-performance human team, only it's digital, which ensures the final output is rich and multifaceted.
So how do these cells talk to each other? Well, there's the official channel through an API server, but what's really fascinating is the unofficial channel, a digital gossip protocol. Kind of like a rumor spreading through an office. One agent shares a discovery with its neighbors, who then spread it to their neighbors. This mechanism, which we see in the gossip event server v2.py code, lets information flow organically and resiliently. This is how a truly collective intelligence emerges without needing a boss to direct everything.
Specialized agents and multiple communication channels are great, but how does the work actually get organized? It all happens through a highly structured process that the system calls a sprint.
What we're looking at here is maybe the most revolutionary part of the whole system. It doesn't just execute tasks, it evolves on its own. With every sprint, the agents themselves propose ideas to make things better, they vote democratically on the best ones, and then they implement them. At the end, they write up meeting minutes which become the memory for the next cycle. Just think about that. It's a system designed to get smarter every single day, completely autonomously.
All right, we get how the system works on the inside. But what's the final result? What does this collective intelligence actually produce? Let's take a look at the artifacts it generates.
The versatility of the outputs is what really proves the ecosystem's value.
It doesn't just generate text. It produces visualizations, reports, user interfaces, and even code. That means its intelligence isn't just stuck in the digital realm. It gets translated into concrete tools that analysts, managers, and clients can use, creating a direct and measurable impact on the business.
Let's look at a concrete example. Using tech like OpenGL and Pygame, the system generates an interactive 3D visualization of the concepts in its knowledge base. Each point is a word, and the colored clusters show different fields of meaning. This isn't just a pretty graph, it's a powerful tool for visually exploring the complex connections in the data, revealing insights that would be totally invisible in a spreadsheet. Another visual example is this similarity heat map. Using libraries like Plotly, the system analyzes how close word clusters are to each other and generates a heat map. The areas in red represent hot zones, where the conceptual density is highest. It's a way to quickly identify the central themes and the strongest relationships within the system's knowledge.
So the crucial point here is that all this intelligence isn't locked away. It connects with the real world. The ecosystem sends reports by email, it powers a web app that you can talk to, and it even integrates with Telegram. That web interface uses a technique called RAG, or Retrieval Augmented Generation. That just means before the chatbot answers, it checks its own knowledge base for facts and context, which makes its answers way more accurate and genuinely useful.
And that brings us to the final thought. We've seen a digital organism that learns, collaborates, self-improves, and creates a real impact. The architecture we've explored with its incremental memory and feedback loops isn't static. It was designed to evolve. The question that remains isn't just what it can do today, but how a system like this, one that learns from every single interaction, will think and create tomorrow.